In this video, I want to take a look at the binomial distribution. So the binomial distribution is a discrete probability distribution which models a number of successes in a sequence of n independent trials. Now, a random variable will follow a binomial distribution if the following conditions hold here. Like you can see then we've got these four conditions here. So for the first condition, we say that there are a fixed number of trials which we denote as n. Then for the second condition, we say that the trials are independent of each other. Now for the third condition, we say that there are two possible outcomes which we denote as success and failure. And then finally, for the very last condition here, we say that the probability of success P is fixed. So this value here for the probability won't change. So these four conditions here, you do need to be familiar with these and memorize these. You can be asked to give these in an exam. So just something there that you need to learn and memorize. Now, moving on to the more interesting stuff here. What about finding probabilities now for a binomial distribution? So let's say we have a random variable x, which follows a binomial distribution with parameters of n and p. Okay. And then what about if I want to find the following probability here? So I've got the probability that our random variable x is equal to some value, let's say little x. Okay, so this value here, little x, that could be 1, 2, 10, 100. Obviously, we don't know what that is. It's just some value. Okay. So to find this probability here, we actually have two methods to do this. So for the first method, we can simply use the following formula. So we've got n choose x here. So n choose x, we then times it by p, our probability of success to the power of x. And then we times this here by 1 minus p to the power of n minus x. Okay. So this formula here would give us this probability. Or what we can also do is use our calculator to find this probability as well. So the way that we do this, and just to point this out here, I am using quite an old graphical calculator, but I would imagine it's the same for any modern graphical calculator. So the first thing that I do is I go into stats mode. Then we press distribution. So I press distribution. So distribution. Then what it gives me here is a list of different distributions. So obviously the one that we want, seeing as we're working with the binomial distribution, would obviously be the binomial distribution. So I click BINM, this stands for the binomial distribution. And then once you press that, you get three different options here, or I get three different options anyway. So I get BPD, BCD, or inverse B. Now in this case here, because we're working out an exact probability, so the probability that our random variable is equal to some value, this would be BPD. So it's BPD here. Okay. But do note that BCD, we will use that as well later on. That's for cumulative probabilities. Okay, but if it's an exact probability like this, we're using BPD. And once you press that then, binomial PD, we get asked for a few different things. Like you can see them. The first thing that it asks for is the data. So it's asking here, is it a list or a variable? Well, here we're working with a variable, so we keep that as a variable. Then it asks for x, the number of trials, and p. So x here, that's this value. Okay, this little value here. The number of trials, well, that's simply n. Our fixed number of trials here, so that's this parameter. And then for the probability p, well, pretty self-explanatory. Again, that's just this parameter here. Okay. So I think for the most part, using the calculator is pretty self-explanatory. I would definitely recommend using the calculator, but you do need to be aware of this formula and how to use it. So that's for finding exact probabilities like this here. What about now finding cumulative probabilities? So what about something like this then? So we've got our random variable x again, which follows a binomial distribution with parameters of n and p. And what about now if we want to find the probability or random variable x is less than or equal to some value, let's say little x. Okay. How would we do this? Again, we have two methods to do this. So the first method is to use your formula book. So what I'm doing here is I'm using what we call the binomial tables. And these will be located at pretty much the very end of your formula book, typically one of the last few pages. And it'll look something like this. And it looks a little bit overwhelming, just giving a load of different probabilities here. But it's actually quite nice and straightforward to use. So what I do here is I need to be aware of the value of n and p. So for example, let's say we've got the random variable x, which follows a binomial distribution. And our parameters here are 6 for n and p equals 0.05. Okay. And let's say I want to find here the probability that x is less than or equal to 1. Okay. We want to find the probability that x is less than or equal to 1. Well, what I can do here is simply use the following table to find this. So n here is 6, so we're in this part of the table, okay? Because here, this is where n equals 6. Obviously, it's not n equals 7, it's not n equals 8, it's not n equals 5. So we're in this part of the table here, these rows. And probability P here is 0.05. So that means we're in this column here. Okay, so we're in this part, these rows here, and we're actually in this column here. So what this table's doing is this is giving me probabilities then for our random variable x being less than or equal to little x. So little x here is these values. This is x equals 0, x equals 1, x equals 2, 3, 4, and 5. So here, little x is 1. This is the probability that our random variable x is less than or equal to 1. That would mean we're looking for this value here. Okay. So it's 0.9672. That is our probability here. Okay, so 0.9672 there. That's the first way that we can find cumulative probabilities. The other way to do this is to use our calculator again. So again, we go into stats mode. So into stats mode, again, we press distribution. So we press distribution. Again, we press binomial here. We press binomial. And now, like we said previously, we're now going to use BCD because we're looking at cumulative probabilities here. So it's BCD now. Okay, so BCD. And again, it almost looks identical. Obviously, the only things that will change is the value of x, the number of trials, and p. Okay, and obviously that depends on the context of the question. And again, I would recommend using a calculator to find these probabilities. However, if you prefer the formula book, that's fine. But do be aware, we can always use the formula book to find these probabilities here. So for the formula book, it only goes up to n equals 50. And you'll also notice here that the probability P is capped at 0.5. Okay, so if it's 0.6, 0.7, and so on, obviously I would have to use my calculator again. So that's for finding cumulative probabilities. Now, you do need to be aware that some questions will be in context, and rather than writing the probabilities like this here, you'll have to kind of translate the actual worded problem into a mathematical question like this. So there's a number of different phrases that you need to be aware of and watch out for. So what I've done here is I give a few examples of what you need to be looking out for. So this is for questions in context. So if I see this phrase here, fewer than, so for example, fewer than 5, and don't worry about the numbers here, I've just picked these as an example. So the phrase here, fewer than 5, what is that telling us? Well, that's telling us then that our random variable x here is strictly less than 5. Okay. So the question here is then, what would that be as a probability? So as a probability, this would be the probability that x, our random variable x here, is less than or equal to 4. So what you need to think about with these problems here is what values for our random variable do we actually want? So I want values of x strictly less than 5, so I want 4, 3, 2, 1, and 0. Okay, we don't want 5 or anything bigger. So in that case then, this would be my probability here. Okay, so if you see the phrase fewer than, this is what we're looking at here. Now if you see something like this here, so greater than or more than, so in this case here, greater than or more than 6, what is this telling us then? Well, here we're saying that x is strictly greater than 6. Okay. So to find this probability here then, what I'm going to do then is 1 minus, so 1 minus the probability that x is less than or equal to 6. Okay. So let's just explain this for a moment. So here, let's just think about the values of x that we actually want. So I'm looking for values of x that are strictly greater than 6. I want 7, 8, 9, 10, and so on. Obviously, that keeps going on and on and on. So the easiest way to find this probability is to consider the fact that the probabilities will add to 1. So in that case then, I've got 1 minus everything below this. Okay, so we want to get rid of 6, 5, 4, 3, 2, 1, and 0. Okay, so I've got 1 minus those probabilities, and that would give me this probability here that we need. Okay, or this is what we're actually looking for, I should say. So in that case then, 1 minus probability of x being less than or equal to 6, that would give me this probability here, okay, that we're looking for. Then if we had at least 10, so again, this phrase here, at least 10, what are we looking for? Well, here we're saying that x is greater than or equal to 10. Now, as a probability then, what would that be? Well, that would be 1 minus the probability that x, so 1 minus probability that x is less than or equal to 9. So again, it's the same concept here as what we had for greater than, more than. Obviously, this is including 10. So in that case, I want to get rid of everything that's below 10. So 9, 8, 7, 6, all the way down to 0. Okay, so again, it's 1 minus. And then finally, for at most or no more than. So in this case here, it's at most or no more than 10. Well, this would be x being less than or equal to 10. So finding that probability is nice and straightforward. It's simply what it is there. So that's the probability that x is less than or equal to 10. Okay, nice and straightforward. You simply use either the formula book or your calculator to find that probability. So that's everything that we need here then for our introduction to the binomial distribution. And I do think that's quite a bit of information to take in. So obviously do take some notes and everything that you need here, or you feel like you'll need to tackle some practice questions. So that's what we're going to do now. We're going to take a look then at 2 practice questions here for the binomial distribution. Starting off with question 1 then, where we have the discrete random variable x, which follows a binomial distribution where n equals 20 and p equals 0.2. And for this question here, we just want to simply find these 3 probabilities here. So we've got part A, part B, and part C. So let's start with part A then. So for part A then, we're looking for the probability that our discrete random variable x is less than or equal to 5. So x is less than or equal to 5. Well, nice and straightforward here. We have 2 methods to do this. So the first method is to use the formula book. So we would use the binomial cumulative tables at the very end of the formula book. Or the second way is to use a calculator to do this. So I'm going to use a calculator to find this probability here. So the first thing that I do is I go into stats mode. Then we press distribution. So distribution. Then we press binomial, because obviously we're working with a binomial distribution here. So binomial. And then finally here, well, this is a cumulative probability here. So it's going to be BCD because it's cumulative. So BCD there. So now what it asks for here is a few different things about the data. So it's asking whether the data is a list or a variable. Well, in this case, it's simply a variable. X is this value here. So that would be 5. The number of trials, well, that would be 20. And then P, the probability of success, that would be 0.2. So input all of those values here and then press enter. And what this gives us here then is this respective probability. So if I round this to say 3 significant figures here, I get 0.804. 0.804 there. And there we have it. So it's as easy as that. That is the solution there to part A. So now we take a look then at part B here, where we're looking for the probability that x, our discrete random variable x, is equal to 3. So again, I'm going to use my calculator to find this, but you could also use the formula that we established at the very beginning of this video. Either's fine, and you should get the same no matter what. So it's going to be almost the exact same path here. So it's distribution. We go stats mode, distribution, and we go binomial again. But here, this probability isn't cumulative, it's an exact probability, so now it's going to be BPD. Okay, so rather than cumulative, it's now BPD. And again, it asks for the same things. So the only thing that will change here is x, because obviously n and p are the same. So x in this case is 3, so change x to 3 and then press enter. And this gives me the respective probability here. So again, if I round this to say 3 significant figures, I get 0.205. Okay, And there we have it. So that's the solution to part B. And then finally for part C here, we're looking for the probability that x is strictly greater than 2. Now, because this inequality here is greater than, to actually find this probability, what we're going to do is subtract the values that we don't want. Okay. So this would be a 1 minus. So it's going to be 1 minus the probability that x. So what we need to determine now is what values of x do we not want here. So if we think about this for a moment, what values of x do we actually want? I want values of x that are strictly greater than 2. So I want 3, 4, 5, 6, and so on. That keeps going, right? So the values that we don't want here would be 2, 1, and 0, because we want strictly greater than 2. So we want to get rid of 2, 1, and 0. So what I'm going to do here then is subtract the probability that x is less than or equal to 2. Okay. So what we need to do then is find this probability here on our calculator. So this is a cumulative probability similar to part A. So it would follow the same path then, distribution, binomial, BCD. So distribution, binomial, BCD. And the only thing that will change here again is x. So x is 2 now. So put 2 into your calculator and then press enter. So what I'm doing here then is 1 minus. So it's 0.20608. It goes on a little bit, but if I ran that to say 5 decimal places there, that's more than accurate enough. Now, if we find the difference here, so 1 minus 0.20608, and then round this here to 3 significant figures, that will give us our answer then. So we get 0.794 there. Okay, so 0.794, and there we have it. So that's the solution to C, and that gives the solution there to question 1. So we just take a look then at one more practice question here. We have the probability that Tom is late to work, and that's given as 0.08. Then the question says, find the probability that in the next 40 days, Tom will arrive late to work on. And then we're given 3 different parts here. So for the first part, that's exactly 1 occasion. For part B, at least 3 occasions. And then for C, less than 4 occasions. Now, for a question like this, where we have this context, the first thing that we should do is choose a random variable to model this scenario. So I choose x here to model this situation. We also need to define the distribution that x follows. So x here will follow a binomial distribution. And we have our parameters here of n and p. So n and p are given in the question. So we're told the probability that Tom is late to work is 0.08. So this probability here is fixed. So p is 0.08. And then for the number of trials here, so n, that's given as 40 because we're looking over the next 40 days. So n equals 40. So n equals 40. And that gives us our random variable there. Okay, so that follows a binomial distribution where n equals 40 and p equals 0.08. So what I need to do now is take each part of this question here, so A, B, and C, and take this question here, so exactly 1 occasion, and translate that into a basic mathematical problem. Okay, so a basic probability. So if it's exactly 1 occasion, what I'm saying then is we're looking for the probability that our random variable x is equal to 1. Exactly 1 occasion. Okay, so for part A then, that's the probability that x, our random variable x, is equal to 1. And to find this probability here, remember there's 2 ways we can do this. We can either use the formula that we established at the beginning of the video, or we can simply use our calculator. So I'm going to use my calculator again here to do this. So I go into stats mode and we press distribution. So distribution. Then it's binomial, because obviously we're working with a binomial distribution. So binomial, and then finally it's BPD in this case because it's an exact probability. So BPD. So then we get asked for a few different things. Obviously the data is a variable rather than a list. X in this case, so this is the probability that our random variable x is equal to little x. So little x here is 1. The number of trials, well that's n, so that would be 40. And then our probability of success p is 0.08. So input all of those and press enter. And what this will give you here is the respective probability. So again, if I round this to 3 significant figures here, what I get then is 0.124. And obviously it should be obvious, or it should be obvious, I should say, It doesn't matter what method you choose, whether that be the formula or the calculator method, you will get the same probability. Okay, so 0.124 there is what you should get to 3 significant figures. So that's part A done. Now for part B, it says at least 3 occasions. So again, I need to take this statement here and translate that into a basic probability like we did for part A. Now I see this phrase straight away, at least. So what that's telling me then is this would be x being greater than or equal to some number. But in this case, that number is 3. So here we're looking for the probability that x is greater than or equal to 3. Okay. So because this probability here is a greater than or equal to, it's going to be a 1 minus when we actually find the probability. The 1 minus probability that our random variable x here. So to choose the values here, well, let's just think about what we actually want. So I want the probability that x is greater than or equal to 3. So I want 3, 4, 5, 6, 7, and so on. So to actually find those values, it's easier then to take 1 minus the values that we don't want. So in this case here, we don't want 2, 1, or 0. So in that case then, we're going to subtract the probability that x is less than or equal to 2. So we'll get rid of 2, 1, and 0. So here then we need to find this probability now on our calculator here. So again, it's distribution, binomial, and BCD. So BCD then, because it's a cumulative probability. And again, you could use the formula book here. So again, there's 2 methods to do this, but I'm just going to use my calculator. So obviously N and P won't change here because we have the same random variable. The only thing that will change is x. So in this case then, x is 2. Press enter again. So what I get here then is 1 minus. So this now is what I've got from my calculator. So I get 0.369. 0.36945 there. Okay. So just rounded that there to 5 decimal places. That's more than accurate enough. So now if I just perform the subtraction here and then round that to 3 significant figures, so 0.36945, press enter, and again, round this to 3 significant figures, then what I get is 0.631. Okay, and there we have it. So that's the solution to part B. And then finally for part C, it says less than 4 occasions. So again, I need to take this statement here and translate that into a basic probability. So if it's less than 4 occasions, I'm saying here that we're looking for the probability that x, our random variable x, is strictly less than 4. Okay, hopefully that one's, quite obvious. So the probability here then, or the probability that we're actually looking to find, well, we want values, say 3, 2, 1, and 0. Okay, so we're looking for the probability that x is less than or equal to 3. And to find this probability here, we can simply use either our formula book or the calculator here. So start mode, distribution. So again, it's going to follow this path here. So it's distribution, binomial, BCD. And the only thing that will change then is x. So obviously the number of trials and the probability won't change. So change x to 3, press enter. And then if I round this here to 3 significant figures, I get 0.601. Okay. And there we have it. So that gives us the solution to part C. And that gives the solution to the very last question, the question 2. And that actually brings us to the end of this video on the binomial distribution.